Hello everyone, welcome back to our channel. Today we are going to discuss about other part of this current electricity. Today our main topics are what is the mobility, what is the resistance and what is the Ohm's law. Everything we are going to discuss about it. But here what is the resistance and where we are using the resistance in our daily life, for what purpose we are using the resistance. See, first I want to say this. Suppose the fan is there at our home. How to control that one? How to control the speed of that one? We are using one device that is called the regulator. That regulator is based on the resistance. Not only that one, when we are using the electric heaters, when we are using the power, because of the power supply, one heater is there, it is giving the heat energy at that one. But how much we require? We want 60 degrees, we want 70 degrees, we want 100 degrees. In kettle, we want to boil that water, we require the 100 degrees. So everything, the heat is controlled by one device that is called the regulator. How we are making the regulator? With the help of the resistance. What is the role of this resistance? It is controlling that temperature in electric heaters and that kettles, and in fans it is controlling the speed of that fan. So this is the use of this resistance. In our few examples only I have given, but many are there. Now come to our point. What is the mobility? What is the mobility? It is the ratio of magnitude of drift velocity to the intensity of electric field. In previous class I mentioned that when you apply the potential difference across the conductor, then what happens? Electrons are drifting from negative charge to positive charge. That velocity is called the drift velocity. We are doing the ratio of magnitude of drift velocity to the intensity of electric field, that is called the mobility. But you remember that mobility is always positive, even it is due to the positive or negative ions. That formula is mu equals to magnitude of drift velocity by intensity of electric field. And one problem also we are doing here. What is that? We are taking one conductor and applying the potential difference. Here intensity we should consider E. But the given data is they have given drift velocity Vd equals to 5 into 10 to the power of minus 6 meters per second. And the potential is 10 volts. Length is 40 centimeters. Here how to find out the mobility? Look here, you know that mu equals to magnitude of drift velocity by intensity. No problem, drift velocity they have given 5 into 10 to the power of minus 6. But intensity they didn't given. We are using intensity is the potential by this length of this one. Here potential is, we are taking 10. Length is we are converting into meters. 40 into 10 to the power of minus 2 meters. Then mu equals to 5 into 10 to the power of minus 6 into, when you are reversing this, 40 into 10 power minus 2 by 10. So this one cancel. Your answer is 20 into 10 to the power of minus 8. It should be right. 2 into 10 to the power of minus 7. Then you can write that unit is meter square, volt inverse, second inverse. Like that we can find out the mobility of the charge carriers with the help of the drift velocity and applied intensity of electric field. Even they didn't given the intensity, with the help of potential per unit length. Potential per unit length we can find out the intensity, V by length of the conductor. Then our next topic is Ohm's law. What is Ohm's law? What is Ohm's law? First of all, it gives the relation between potential, electric current and resistance. 3 parameters are involved in that. Then what is the statement of this one? At constant temperature, potential is directly proportional to current. When we are increasing the potential, current is also increases. So how to express that one? Look here, potential is directly proportional to current. When instead of proportionality we are getting one constant. This R is called resistance. R is constant and R, that name is the R is the resistance. And what is the role of this one in our current electricity and whatever it is? The definition for resistance is it opposes the flow of electric current in the conductor. Suppose we are walking, which is opposing your motion, our motion, friction. Like that, current is passing through the conductor. One parameter which is opposing its flow of electric current, that is called the resistance, that is mostly represented by R, and the unit for R is ohm, and you can mention with this symbol also. This is the resistance, and you know what is the definition for the resistance. And from this you can find out the resistance. R equals to V by I. R equals to V by I. So Ohm's law is V equals to IR, and from this we can find out the resistance. R equals to V by I. Potential by current is giving the resistance. And based on this Ohm's law, the devices are classified into two types. First one is the ohmic devices and second one is the non-ohmic devices. What are the ohmic devices? The devices which obey the Ohm's law. The devices which obey the Ohm's law are called the ohmic devices. What are the examples for that? Metals, linear metals and linear conductors are the examples for that ohmic devices. So potential is directly proportional to current in this. When we are increasing the potential like 1 volt, 2 volt, 3 volt, automatically current is also increases. When we are drawing the graph between potential and current for the ohmic devices, suppose we are taking current and this is the potential. This is a straight line passing through the origin. From the Ohm's law, you know that V equals to IR. Then R equals to V by I. Suppose the angle is theta. From the graph also we should calculate the resistance. R equals to tan theta. R equals to tan theta, nothing but opposite by adjacent V by I. Suppose if theta equals to 45 degrees, here resistance is how much? Tan 45 is the 1 volt. Like that we should calculate. Then one more thing I want to say to you. Reciprocal of resistance. Reciprocal of resistance. Reciprocal of resistance is called conductance. Okay. Reciprocal of resistance is called the conductance. We are representing with capital G. G equals to 1 by R. So the unit for resistance is ohm, but for this unit is ohm inverse is the unit. This is called the conductance and that is the resistance. One type of devices are over. The next thing is the non-ohmic devices. What are the non-ohmic devices? Same, the devices which does not obey the Ohm's law are called the non-ohmic devices. Semiconductors, then vacuum diodes, all belongs to few are belongs to these non-ohmic devices. But when we are drawing the graph in the case of semiconductors, we won't get the straight line. Non-ohmic devices, the graph is like this. We are taking, this is the potential and this is the current. We can get the graph is like this. Examples for non-ohmic devices are semiconductors, germanium, silicon, vacuum diodes and electrolytes are examples for non-ohmic devices. So from this we are getting the clarity how to find out the resistance. Then one more thing, resistance does not depends only on potential and current. It depends on the dimensions of the conductors also. That we should write it. Here resistance is directly proportional to length of the conductor and inversely proportional to area. When we are writing this one, you are getting one constant rho into L by A. Here rho is one more constant. This is the specific resistance. This is the specific resistance or resistivity also we are calling. It depends on the nature of the material. Does not depends on this resistance. It is constant. Suppose the gold it is different, the silver it is different, iron it is different. So it depends on the nature of the material. So from this, suppose we are going to one metal. but different lengths. R1 by R2 we should write it. L1 by L2 into A2 by A1. Suppose if area is constant, A is constant. Now we are going to discuss about different parameters, how the resistance is depends on the length if area is constant, how it is depending on area if length is constant and everything. So R1 by R2 equals to L1 by L2. Simply we should write it, R is directly proportional to length. Like that, if L is constant, means we are not changing the length. How to write this expression? This resistance is inversely proportional to area. But if you are taking the wire, area is directly proportional to radius square. Pi r square, instead of pi we can take the constant. It should be right, R1 by R2 equals to A2 by A1. Suppose they are mentioning that radius, we can write it R2 by R1 whole square. This is when the resistance is depending on the length and area. Like that, we should express this resistance in terms of volume and masses and density also. Here, see, resistance equals to rho into L by A. But instead of area, how to write this area in terms of volume? Volume by length is the area. Then R equals to rho into L square by V. V belongs to volume here. If the question is like this, if the wire is stretched, we are taking one wire, we are stretching that one. Why I am stressing on this? Here, in this case, volume is constant. Volume is constant means immediately how can you give the relation between resistance and length? R is directly proportional to L square, because here V is constant, V is not potential, here V is the volume. So we can write it R1 by R2 equals to L1 by L2 whole square. Don't confuse. Here when area is constant, resistance is directly proportional to length. When volume is constant, like the wire is stretched, volume is constant, resistance is directly proportional to length square. Then like this we should express, you can give the relation between resistance and mass of that one also. Rho into L square by, instead of volume we should write it mass by density. So rho into L square into density by M. When we are going through the single conductor, single material, two wires we are taking, R1 by R2 equals to, we should take it L1 by L2 whole square, D1 by D2 into M2 by M1 to M2 by M1. So don't stick one formula. Resistance we can measure in terms of potential and current, or in terms of length and area, in terms of length and volume, in terms of length, volume and density, and in terms of mass also we are going to calculate. So these are the depends of that resistance of the conductors and ohmic devices and non-ohmic devices we discussed.